Let's take a look at where we left off last time by clicking the play button at the top of the screen. You can see we have some camera movement, but it's pretty static and not very dynamic. It would be helpful as we're picking up objects and running away from this player if we can move this camera around the scene. To better help us navigate the environment, press the play button again at the top of the screen to stop our game. Now let's open up our camera follow script by double clicking it. Once open, we'll make some changes to the script so that when we move our mouse, the camera will follow. At the top in the variables section, let's add a variable that we can use to adjust how quickly we'd like the camera to rotate. This is important since the speed in which mice move can vary depending on if it's a gaming mouse or just an ordinary house mouse. Since our camera is going to be pointed directly at our player and rotating at an angle, vertically and horizontally around our player, we want to create a couple of variables that can store the angle in which our camera is moving. Add the following two variables. Next, within our start function, we want to set the value of the two variables we just created. We're setting them to the respective y and x axes. Notice within the code, we follow the word transform. We have the words Euler angles. The keyword transform gives us access to the x, y, and z rotation properties of the camera that this script is attached to. Euler angles represent three-dimensional rotation by performing three separate rotations around an individual axis. In this case, the axis is the player. In the late update function, which runs every frame, we want to create a variable that will store the horizontal movement of our mouse on the x-axis. In order to control how sensitive the movement is, we'll take the mouse's movement angle and multiply it by the rotation sensitivity variable that we created earlier. Let's return to Unity and let's take a look at how I knew the mouse x keyword would give me the access to the value of the movement of the mouse on its x-axis. Back in Unity, in the top menu, select Edit, then Project Settings. Within the Project Settings window, select the Input Manager section. In the Input Manager section, notice that there's a Mouse X section, and towards the bottom, in the Axis section, you can see that there's a drop-down for the X-axis. This is what gives us the ability to access the X-axis on our mouse through the Mouse X keyword. Let's return to Visual Studio and set up the rest of our code. Back in Visual Studio, under the code we just added, we'll add very similar code, but instead of us getting the mouse x-axis, we'll get the y-axis. And again, we'll store that value in the mouse y's movement and control the movement by multiplying it by a rotation sensitivity variable. Below the code we just created, let's create another variable called rotation. Its data type is quaternion. Quaternions are used to represent all of the rotations of an object. So by making the value of this variable equal to quaternion.euler, we're essentially starting or storing within a single variable all of the vertical and horizontal variable data. So here you can see it's representing by up, down, left, and right movement. You can see in the last axis we actually entered in the value 0. This is the z-axis. And the reason for this is we won't be moving the camera on that axis. That would cause the camera to rotate. Lastly, we need to multiply the rotation variable we just created to the desired position variable. Recall that this variable is used to set the final position of our camera. So by multiplying the rotation by the offset, we're essentially using our mouse's movement to further offset the camera. Now let's return to Unity to test this out. Press play at the top of the screen. You can see that our camera now follows the movement of our mouse, both horizontally and vertically. I find that the movement to be a bit wonky, so let's stop playing and adjust the value. I find that a value of 3.5 in the height parameter gives me pretty good results. In the next video, we'll take a look at adding some excitement to our game by creating a negative energy blaster that will emit itself from the player when a button is clicked.